So first of all, we will draw the graph of cos and try to see some of the features of cos, like domain, codomain, and what is the range of cos function. And then we will draw the graph, and then I will try to find the inverse of cosine function. So cosine function has came from this particular unit circle. That means the radius is of length 1. So if I take a point P here and the angle is theta, then this particular coordinates say x and y, then P will be x comma y, and this coordinate is also same as cos theta comma sin theta. You can see that x is cos theta here and y is sin theta. So the x coordinate in this particular circle always represent the cos of that angle. Okay, now what is cos of, like, suppose this is 30 degree. That means this particular point will be represented like this: cos 30, sin 30. But since in this particular lecture I am interested in cos, so I will be more focused on that. So now I will draw the triangle, and this length is basically cos 30. Now if I draw something like this, like 60 degree, suppose this is 60 degree, then this portion is basically cos 60. The length in the x-axis, this represent our value of cos in radians. Now I will try to draw the graph of cos x from this unit circle. So if I try to find the graph of cos, then I can see that this length is 1. So at 0 degree the graph will start from 1. Then if I increase the degree little bit, then I can see the value will decrease. This will start decreasing. It will keep on decreasing till the value is vanished, 0. So that means from 0 to 90 degree, like suppose this value is little bit lesser. Now this value will be more or less. Like I am just focusing on the length in the x-axis. Now if I consider this triangle more lesser, so now if I plot this, and this is from 0 to 90 degree, so from 0 to 90 degree cos has decreased. Okay, now in a similar fashion, now from in the second quadrant, if I draw lines, horizontal lines, I can see the lines are increasing. But these lines, the maximum line is basically -1. So from 0, at this point to this point, the horizontal line has increased, but in the negative side. So it will go up to -1. So this is basically our pi, and this was pi by 2. And then from increasing, it will keep on decreasing. It will decrease till it becomes 0, because at last I can see that it has become 0. So now it will go up. Why increasing? Because I can see that in the negative side the lines are decreasing. The lines are decreasing means that the magnitude has decreased, but in the negative side. If the magnitude decreases in the negative side, that means the values are increasing. Suppose it was at first it was -1, then -1/2. Okay, then minus, suppose 1/3. That means these values are increasing. So that is the reason the function has increased up to 270 degree. And after 270 to 360, after 270 to 360, or which is same as 0 degree, I can see that the value will increase, the lines will increase. So magnitude is increasing, and also since it is moving upward, so it is an increasing function in this particular fourth quadrant. So this is my fx equal to cos x. Now I will take a little portion of that so that this function becomes 1, 1 and on 2. Because if I see in this particular function, I can easily see that this function is neither 1, 1 nor on 2. Because this function continues like this. So this function is neither 1, 1 nor on 2. So in order to make this function 1, 1 and on 2, I need to restrict this function. So how much portion should I take from this cos function so that this becomes 1, 1 and on 2? So just take from 0 to pi. Take from 0 to pi. Because in this region, if you try to draw horizontal lines, you will see that the line will particularly cut exactly at one point. If you draw horizontal lines like this, you can easily see that it will cut exactly at one point. That means this function is 1, 1. If I restrict the domain, from 0 comma pi to r, then this function is 1, 1. Is this function on 2? But not on 2. Why? Because the codomain is r and range is from -1 to 1. Since the codomain and range are not same, I cannot say that this function is on 2. So now I have to set another restriction. So I will set 0 to pi to -1 to 1. Now this function, I can see that this is both 1, 1 and on 2. That means f is invertible. So f inverse exists. So how f inverse will look like? F inverse will look like from -1, 1 to 0, pi. And if I say this as g, then gx will look like, the notation is cos inverse x. Or if I change the say cos inverse y, if I say where y is taken from -1 to 1 and here x is taken from 0 to pi. So this is my inverse function. Now how to plot this inverse function? So my restricted cos function is from 0 to this much, from 0 to pi. So this is my this is -1, this is 1. So this is my fx equal to cos x. F 0 to pi to -1 to 1. And now I would like to ask, what is the graph of the inverse of cos function? So to get the inverse of a cos function, what do I need? I need to change the two coordinate axes, x axis and y axis. If I change, I can see, so this is origin, this is So this function has decreased towards the x-axis, like decrease but moving towards the x-axis. Now similar thing I will do. So what are the coordinates? What is the coordinate of this particular point? Coordinate of this particular point is 0, 1. This will be 0, -1. This point will be pi, 0. Okay. And this point will be pi by 2, 0. Now this point, if I plot in this inverse function 1, 0, 1, 0 will become, 0, 1 will become 1, 0. Because remember one thing, in the previous case, in cos x, the x-axis was representing the angles and y-axis was representing the values, the outcomes. So x-axis was giving me inputs. From x-axis I am taking inputs and y-axis was giving me outputs. But in this inverse function, my x-axis, my output will be in x-axis and y-axis will work as input. From y-axis I will take the inputs. Okay, now I have to plot 1, 0. So this is 1, 0. Then pi by 2, 0 will, so this will be pi by 2, this will be minus pi by 2. So I will get 0, pi by 2, 0 will become 0, pi by 2. So this is another point. And pi, 0 will become 0, pi. So this will be my 0, pi. Okay, now from 1 in the positive direction it has moved. So from 1, the positive direction is this one. So it will move like this. Okay, now it has crossed the line and moved towards the negative of that line. So it will move like this. So this will be the graph of our fx equal to cos inverse x, or gx equal to or cos inverse y. So this is the inverse graph of cos inverse. I have just simply exchanged x and y axis. After that I have got this particular graph. So now I will try to highlight some of the observation from these two graphs. That you can see this function, this fx equal to cos x function, from 0 to pi, it has decreased. Okay, and now in the inverse function also this function has decreased. So that means both cos x and cos inverse y is a decreasing function. And the domain of cos inverse is, it is taking input from -1 to 1, so the domain is -1 to 1. Sorry, the domain is from 0 to pi, and the codomain is -1 to 1. So the domain of cos inverse is -1 to 1, and the range or codomain is 0 to pi. So this is the domain and codomain. Okay. Now similarly for tan also, if I try to draw the graph of tan, if I draw the graph of tan x, how to draw? Tan x can also be written as sin x by cos x. So I know that if cos x becomes 0, then the denominator will become 0, and at that point tan will be undefined. So I will check those points at which cos will become 0. Okay, and from this I can see then at which points cos becomes 0. So this is pi by 2, this is 3 pi by 2, this is 5 pi by 2. So you can get an idea that at odd multiples of pi by 2, this is 1 pi by 2, this is minus pi by 2, then it will be 0, 1, minus 3 pi by 2. So at odd multiples of pi by 2, cos becomes 0. From this I am getting x equal to 2n plus 1 pi by 2, where n belongs to z. So at these points the cos becomes 0. So tan is not defined at this point, because at this point the denominator is 0. Tan is simply sin by cos. So now what is the domain of how should I set the domain? My domain should be R minus this particular set. Say this particular set, I am defining this set, say S equal to 2n plus 1 pi by 2 such that n belongs to z. I am removing these points to R by fx equal to tan x. Now this is my function. And domain is, this one is domain, this one is codomain. Okay. Now at these particular points, those points at which the tan is not defined, I will draw asymptotes, because there cannot be any particular value at these points. So I can see odd multiples of pi by 2. Suppose this is 0, suppose this is pi by 2, then there will be pi, then there will be 3 pi by 2. Likewise this point will be minus pi by 2, then minus pi, then minus 3 pi by 2. Now between these things, the value of tan from 0 to pi, if you know certain values, you can easily plot them that this function is increasing. Now this is an asymptote, that means it will increase up to infinite. Similar thing will happen in 0 to minus 2, 0 to minus pi by 2 also, and then again there will be a repetition, because tan is also a periodic function. So likewise, so this is the graph of tan. Now one thing you have to see, that this function is not 1 1 and not on 2. So I will restrict this. How should I restrict? So I can pick the easiest one. So I will just pick this part. I will pick this part, and I cannot include minus pi by 2 and pi by 2 because they are already excluded. They are excluded from the domain. So I will take open interval minus pi by 2 to open interval pi by 2 to not R. If I take R, then the range and codomain will not be same. So it will not be on 2. So I will have to take this. What should I take? Okay, this time I can take this as R, because our range is R, so that is why I can take this as R, not as the previous cases. So in this case, okay, by f of x equal to tan x, now I can see that this particular function is both 1 1 and on 2. So I have just chosen this portion from the whole part. Now if I just simply, this is minus pi by 2 to pi by 2. So this is the graph. This is the graph of sin tan x, where this becomes 1 and 1 2. Now what will be the inverse of that? So I will just rotate or swap the x-axis and y-axis. So it has increased towards the y-axis. So that means from 0. So this is positive y-axis. So it has moved like this. So if I swap or exchange this x-axis and y-axis, from 0 it will increase towards like this. I will draw this curve in this fashion towards x-axis, and now it has decreased towards the negative y-axis. So I have to draw the similar fashion towards the negative x-axis this time. So like this. So this is my graph of tan inverse x. And what is the domain? Domain will change. So domain will change. Domain will be r2 minus pi by 2 to pi by 2. That means this point is basically pi by 2, and this point is basically minus pi by 2. So this is my graph of tan inverse x. Now is this function increasing? Is this function decreasing? So in case of tan, I can see that this particular function is increased towards infinite. It was increasing towards plus infinite, and this is decreasing in this quadrant. This is decreasing towards minus infinite. That means if I thoroughly move like from this portion to this portion, if I move like this, I can see that the values are slowly the values are increasing. So the tan x function from minus pi by 2 is basically a increasing function. Okay. Now what about tan inverse? So tan inverse is also increasing in its, so it is keep increasing till up to pi by 2. So from minus pi by 2 to pi by 2 it has continuously increased. So this is also increasing function. So both tan and tan inverse are increasing function. Okay. Thank you for watching the lecture. I will see you in the next class.